All right. Really excited for this one. Totally unbiased. But just to start off, I'm Graziella. I'm an investor at Finality. I'm also one of the founders of the Shared Security Alliance. And these are my incredible panelists here. We're going to talk a little bit about interoperability. What does that look like with shared security? All these networks that are building on top of Eigenlayer, Babylon, Solr, you name it. How do these different protocols communicate? How do we make sure that things can interoperate smoothly? So to start off, if you guys could just introduce yourselves, introduce the project, and how it's related to shared security, whether you're building on top of it or kind of working with projects in the space.
Yeah, I can start. I'm Altan, one of the co-founders of Nuffle Labs. Nuffle just spun out a year, so we announced that three weeks ago, I think. Yeah, and background is technical. Currently, we're building. We were the ones that built NearDA, so I would say like NearDA is a AVS built on Near, just uses Near security, and then Near Fast Finality Layer is using NearDA plus an AVS that can attest to state roots that can do ACK state, so it uses Eigenlayer security. So we have both like experience with, I guess, Near itself as a sort of a shared security layer, but also using Eigenlayer to build pretty much like an ACK state model.
And I am Tommy. I'm a product manager at Polymer Labs. At Polymer, we are a roll-up, and we are focused on bringing interoperability to other roll-ups, really with the end state of infinite connectivity and beyond, and really aggregating a network layer of roll-ups and other ecosystems as well. We, as a roll-up, are a consumer of a lot of these shared security, one of which we have within Eigenlayer, we leverage Lagrange and other different types of AVSs.
Hey guys, I'm Yorke. Leading the protocol team at Hyperlane. Previously was doing basically stuff around DeFi, stablecoins, at Cello. Hyperlane has been in production for a couple of years, so it's a interoperability protocol that moves data between chains. There's a general message passing interface. Shared security allows us to kind of layer economic security on top of that protocol in a way which I guess has like a low cost of capital. So it's kind of like a nice, convenient fact that there's like a bunch of stake locked up in all these systems already, like in Near and in Ethereum, and we can kind of build additional protocols on top of that to leverage that capital that's already kind of committed.
So Yorke and Tommy, you're both of your projects are these message passing, data passing protocols. How should we think about the differences between the two? And for developers who are choosing, which one to use, like why might one system be better suited than the other based on their specific needs?
Sure. So from the Polymer side, as I mentioned before, we are a roll-up and we are focused specifically on targeting initially the superchain. So OP stack rollups, those are really, we believe, the long tail of where rollups will be. And right now, only around 20% of them are connected, so that is really the target market that we're initially trying to go for. I also think it's prudent to call out that there are really two things that we need to call out when we talk about interoperability. There, especially with Polymer, you have the concept of actually sending a message, and then you have the verification method. And actually sending a message is where we are really leveraging IBC as a battle-tested, credibly neutral framework, and we believe that that can scale at a high clip, which is required because rollups are also growing at a very high clip, especially as we start getting into a world where there are roll-up applications, where applications are starting to build their own roll-ups, and you really need a scalable framework for that. On the verification side, we try to stay relatively neutral. Since we're a roll-up, we're able to read and write from Ethereum. So a big pro for Polymer is that we are able to read and aggregate the state of all of these other OP stack rollups, which means we're not just verifying transactions, we are also verifying the state of these rollup applications. That's a unique twist, especially when we're talking about with Ethereum. The constraints of that, though, are that Ethereum is roll up to L1 relatively slow, especially when we're talking about 30-second type latency. You are dependent on a 4-minute batching sequence. You're dependent on a 16-minute finality rate for Ethereum, and you're dependent on the proposer, which can be anywhere between 30 minutes and an hour. So you're quite constrained on just pure latency. And with that, there are many different ways that we can leverage verifiers. AVSs are a huge part of it, and that's where pre-confirmations can really come in. So, and that's really what this is all about. So not just natively trusting Ethereum, but we can also verify. Hyperlane works, is right now working on an AVS as well, and that's something that we can also leverage. So yeah, there's a lot of different ways. So you have the verification, and then you also have the actual message sending.
Yeah, I think that's a good framework to think about it. The message sending as like the transport layer or like the application interface. So as an application developer, if you're writing smart contracts, this is kind of the function that you would call on-chain that requires you to like do some API encoding. That's what we talk about when we say the messaging interface. And then the verification interface is basically on the destination chain. How can you have confidence as an application who is receiving a message that this message was actually dispatched with these bytes from this contract on the origin chain, at block height X. And yeah, IBC is kind of a framework from the Cosmos ecosystem that has been attempting to address this problem kind of at multiple layers for many years now. The Cosmos SDK has kind of a bunch of nice capabilities which ship out of the box. So there's like the default verifier is the Tendermint light client. And so on a destination chain, you can verify the consensus of the origin chain's validator set. But in the Ethereum ecosystem, with rollups and these other kind of emerging execution layers, we have quite different consensus. And so the verifiers that we have available off the shelf are not so great. Like the Ethereum light client is not so great. And even kind of the just smart contract VM is quite different from the kind of general purpose capabilities that the Cosmos SDK has. And so at Hyperlane, we kind of reimagined some of IBC and the Cosmos SDK's approach to interop in kind of like an Ethereum centric lens. And yeah, we also are kind of, we try and, I guess, remain agnostic to the verifier layer. So applications can kind of configure their own verification constraints. We're actually doing this in production with Renzo. Renzo is actually like running sovereign validators in our system. So they're not taking on just like a completely third-party or like counterparty risk. They actually have their own validators who are securing their Hyperlane messages, which is minting and burning their asset across a bunch of L2s. It's a pretty interesting case study if you guys want to take a look at that. But yeah, Renzo and some of these LSTs are basically able to provide stake, which can kind of delegate to validators who are providing pre-confs on these rollups, because we don't have a good consensus mechanism for those rollups right now. We basically have Ethereum, which the floor is probably 30 minutes on like actually getting a good guarantee, which for a consumer grade experience is just too slow. So we need pre-confirmations. The way that you can actually use those pre-confirmations on a destination chain with confidence as an application developer is you want to have, some mechanism by which validators will be punished if they lie, and this is where AVSs come in. So yeah, Renzo and some of these LSTs are kind of have been collaborating with us on basically kind of the synergy between their application layer of moving across L2s and their capital layer of being able to recruit this like delegation to contribute security to this interop protocol.
I would also say that Hyperlane and Polymer are we may be the only two that are interop protocols that are verification agnostic.
Got it. Thank you. That's super useful. Altan, I've heard a lot of pre-confirmations thrown out there. How does Nuffle play into that with the fast finality layer? Is that complementary to Polymer and Hyperlane, or kind of almost something you would use in place of that?
Yeah, our approach is quite different in a sense. So we I guess, like, was looking at the Hyperlane architecture. So as long as you're using a DA, like every rollup uses a DA, let's say, we're seeing a lot of alt DA implementations, like start to near DA with. As everybody dumps their sequence, right? It lives there. We started with that approach, and then we'll eventually like evolve to integrate with EigenDA or the Celestia. Doesn't really matter. As long as we get to sequence, and then we can prove that sequence, that's what we do. So the architecture looks like pretty much the operators, in that sense, grab the sequence from the DA layer, and then pretty much do a consensus around them and say, hey, this is the actual state. So it becomes like 3-4 second finality compared to like Ethereum's 12 minutes finality, obviously with some eigenlayer guarantees, right? So that's the sort of the spectrum that you're going for. And then the idea is quite similar in a sense, like verifiers become the eigenlayer sort of operators, and then you give that as an API for applications to use. So what can happen is like you're doing something in OP, you did that, and then you get that state attestation, and you're pushing that as an application developer to ARB and say, hey, I've already seen that OP finalized in this system, not only on Ethereum, but in the fast finality layer, and I'm pushing that to do something else on Arbitrum. So it's quite like, it's not a messaging protocol, but you can build a messaging protocol or a bridge or a cross-chain DEX, cross-chain lending, whatever, on this platform. And yeah, we're pretty much on testnet currently. The problem is like audits take time, so we're waiting for that, but mainly going to mainnet hopefully in one or 2 months. So the idea is quite similar approaches. I mean, crypto is kind of funny in a way that everybody looks through the same problem and then starts to kind of coming from Cosmos or Near somewhere else. We propose different problems. So that's how we kind of, being builders of Near DA, wanted to go with that approach.
Awesome. So with that kind of background on what each of you is building, I want to dig into what is it, if there are specifics about the shared security architecture that unlock potential in your projects that previously wasn't there. So, specifically, is shared security almost inherently interoperable? If multiple networks building on top of, let's say EigenLayer or Babylon are actually under the hood sharing the same validator sets or like a subset of the same validators, does that create the incentives and technology for protocols to be more interoperable just by virtue of sharing validators? That's on one side. And then on the other side, the fact that maybe all these protocols no longer need their own tokens. Are we maybe seeing, fewer reasons for liquidity moats and for projects to actually try not to be interoperable? Just curious, feel free to answer in whatever order, how you guys see those.
Yeah, I can go for this. So when we started we were Near modular within Near Foundation. Our approach has always been, there's always, let's just not build a new L2. There's already existing security across everywhere. Let's just grab it. So that's how we started. Our modular approach has always been, let's just not build a new blockchain. Let's get everything that exists and build something on top of it. I would say using shared security obviously allows us to kind of, for example, if you were to use DA, if you're EigenDA, everybody's using EigenDA, that makes sense. But I would just take that question and maybe approach it in a different way, right? You're using the same Ethereum validators. Eventually, you would want to use validator sets from Near or let's say Babylon or something. So that's something we're thinking about publicly, at least over the last 2 weeks or so. But how do you sort of not only use Ethereum native assets, but also use other native assets as well, and build this sort of becomes an ag layer of restaking, and not only you're not using Ethereum validators, but also everyone that's in crypto pretty much do that. So that's kind of not the best sort of answer to what you say, but this is like how the mental model we're going with.
I would say, as far as shared security is concerned, being interoperable, I'd say it's an augmentation, not a substitution. Now again, just breaking down the theme of validation and message transfer, at the end of the day, you still need something to transfer that message, and that message could be a transaction itself, that message could be arbitrary, that message could also be the state. At the end of the day, when you are talking about interoperability at the most secure level, you need to make sure that the states of these chains are getting confirmed. And I think that's where the augmentation comes in, because with shared security, it really enables something like pre-confirmations, where you can have confidence that an unsafe block will become a safe block. There's also a tremendous amount of work that we could get into when you talk about pre-confirmation with fast finality with like an intent-based protocol. That's a lot of different modular pieces that can create a very confident, fast-working system. And I think it's, so yeah, in my opinion, it's just more ways to add to interoperability. It's still not going to purely be a substitute.
Yeah, I think this is an interesting question. Maybe approaching it from like a market macro perspective. That's maybe kind of like a more controversial take, but I think like when there's less capital inflows to an ecosystem, you need to be more efficient with the capital that is already within the ecosystem. And we've seen this in DeFi, right? Like there was kind of, you know, consolidation to some, you know, more like blue chip DeFi protocols who maybe have been more efficient with their parameterizations or just like their collateral and are kind of actively managing it more carefully. And I think the same can be said for the infrastructure layer, where you know, there was maybe a an L1 boom for a few years, which kind of was a bunch of capital influx to the ecosystem, which was funding a lot of ambitious kind of research and innovation, which was quite useful. I don't want to diminish that, but I think the ultimate kind of outcome of that influx of capital was technology, but there was, I think, often very little reason for that technology to have its own token. And given that there was kind of already kind of, I think, a large swath of the community who were already ETH aligned, but maybe weren't aligned with one of these other L1s, or basically shared security is a way to bring the frontier of innovation and the kind of like technology that had been funded by the influx of capital to all these other L1s to the Ethereum ecosystem. And this is kind of like, this is what's happening with even rollups, right? Like the rollup centric roadmap is a way for people to innovate while staying ETH aligned. And yeah, I don't know if that's like a spicy take or not, but yeah, I think like shared security from my view is kind of similar in the sense where like we can continue to push the frontier of innovation while maybe having more cooperative incentives rather than competitive incentives. And I think even the Cosmos ecosystem potentially set out to with a similar goal, but ultimately failed to kind of cement Atom as this like ecosystem-wide asset that people had, I guess, already commitments to. I think Ethereum, I'm trying to think of like what a good example is. Maybe like Lido or some of these other LST products that have gotten to like the consumer grade yield product that's like, in Coinbase, have created basically like this kind of race to build atop those products, which already have a lot of like sticky consumer usage. And I think just the longer tail of L1s, you have to get your users to buy some token, and that's like a huge barrier to entry. So this is just like, I think, a nice way to maintain the pace of innovation while like avoiding some of the competitive outcomes.
I think also on the token side of things, everything that you said I agree completely with. It's also just, frankly, putting more pressure to move away from protocols just creating governance tokens. They're now being forced to actually have real utility to make a token, especially if we're talking about an Ethereum with rollups, to make that token meaningful and worth buying into.
Still governance tokens, though. That's the problem.
Yeah, I tend to agree. That's one of the things I'm most excited about, but also I think is still very uncertain how that will play out. You know, are networks going to end up dual staking or just foregoing a token altogether? What does that even mean for Web3 if you don't have a token? Are you even a crypto project? I don't know. But any other ways you guys think that shared security might influence the interoperability landscape over the next couple of years?
Yeah, I touched on this earlier, but one case study that I just wanted to highlight, which I think is kind of interesting, is that shared security, I think, uniquely enables, was this Renzo case study where you already have this LST who wants to basically make their product as accessible as possible to all of the users of crypto. Today, that looks like L2s rather than L1, right? So they don't want to just only have their product accessible on L1. They want it to be available on this long tail of OP stack rollups. And there's a synergy between shared security protocols like EigenLayer, which allow Renzo to basically provide economic security to an interoperability protocol like Polymer or Hyperlane, and actually making their product available across these L2s in a way that is a consumer-grade experience. So they can kind of, take some percentage of their treasury and delegate it to Hyperlane validators, and take some separate percentage of their treasury and basically lock that up as collateral for basically minting on L2s. And now they can have their users basically access their products on these L2s with lower fees and with kind of like a more consumer-grade experience where they're not waiting for Ethereum finality. And I just think that's like a cool synergy of the application layer and the infrastructure layer where that's, I think, uniquely enabled by like shared security where, if I guess the alternative would be they would have their own chain and they would have kind of validators who are securing the users purchasing their asset, but this is a case where they're using Ethereum consensus. They're building this user product on top of Ethereum staking, and they're making that product available on non-Ethereum chains using Ethereum security. I just think it's pretty cool. Yeah.
Yeah, I can go next. Like, the question I always ask is, do you really need a new blockchain when you have shared security? Like, you have already bootstrapping security from Ethereum, which has been around for a while. And then what does that allow us to, like, if we can do that, do we really need interoperability, or we just build like AVSs all over the place and being able to build the verifiable cloud that we all talk about? So that's kind of what I'm excited about, is that like I don't want to see, although it's our business, I don't want to see new blockchains myself to go and to think like that excites me. But apart from that, I think we will kill that sort of interoperability thing that we've been talking about for the last like 5 years or 6 years or something, and then being able to grab security from everywhere to be able to do anything verifiable, really.
You said we're going to kill the interoperability thing.
The name is it like it's like, because we always talk about it's like this needs to be interoperable between these different blockchains. What if you think about a world where you can just grab security from everywhere and build applications that people will use, not a new blockchain, right? Like that's kind of the vision we have, is like we should not build a new blockchain to be able to do new things, and that's why we use EigenLayer.
Yeah, the key to interoperability is to stop talking about interoperability. I mean, interoperability was a Web 2 problem as well in the 90s, and
consensus is like Google, yeah.
But I think there are a lot of different use cases that will come out, especially when we start thinking about the future of AVSs. We are literally in the very early stages of it. one interesting thing to think about is interoperability as a service. So maybe not necessarily just traditionally, it's very fee-based and it's transactional. But there could be this idea of taking pools of security and actually offering interoperability more as like a subscription model. And that's something that is exciting and something that we're currently thinking about and looking into.
I want to give you guys a chance to ask any burning questions you may have for each other.
I have a maybe spicy question, because a lot of people are hating on Ethereum kind of leaning into adopting DA-like qualities. And I know, yeah, Near's been pushing, Nuffle's been doing a good job at competing. And I'm curious how, what's the differentiation for DA layers? And is it simply just like amount of stake in the system?
That's a very good question. I mean, the way we think about it is, well, we started doing this in August last year, where we looked at like Near tech stack and said, hey, this is a sharded blockchain. There's a lot of data availability because of that reason. And so we get like, I don't know, 24 megabytes per second data throughput, very cheap DA that actually saw one of the RSS3 in top 20 in L2 beat saw their call data costs from 1K to like 10 a day. But the thing is, like, at the end of the day, that does not value accrue to us, right? Like, we're aware of that. Like, so we started building things on top that make sense, that you can use this cheap and scalable DA to do what else you can do. So that's how we see it. It's this additional, some rollups actually considering like doing a dual DA where your final DA is Ethereum, but you can also post it to us to do something cool with it. And like NFFL is an example of that. But yeah, I was just looking at the problems and seeing like how do we innovate that problem set with a different blockchain. That was a question to me. So
Yeah, I guess it's more specifically, like, Ethereum maybe has this restaking capability that maybe some of these other DAs don't currently have, or maybe are in the early innings of. Is that kind of like...
What if I say we add restaking security to Near DA?
Woo.
It's in our roadmap. We're just thinking about it. But the problem becomes like, how do you pay back? Right? I think a lot of people are doing AVSs without thinking back how you pay the validators, right? I mean, there's going to be token emissions that pay that, but in the DA sense, like, if it's cheap, how do you pay? So you need a service built on top to be able to pay that back. And I guess like interoperability for its sake, it's a good example, because you guys are giving a service to everybody, right? Roll-ups and others to do something that you weren't able to do it before.
I can go ahead with one more. So obviously, I think we all would benefit from an ecosystem where there are hundreds, if not thousands, of rollups. Obviously, that is quite a, we have quite a way to go to get there. But I'm curious if you guys are bullish or bearish on the idea that we will have hundreds of rollups by the end of the year. Maybe we should just say 100 at this point, because it's just not scaling immediately yet.
Yeah, I mean, I think we already do have hundreds of rollups. Like, part of our onboarding task has become like, get your own Caldera or Conduit rollup and start doing stuff. And I think this will, like, the line between, like, testnet and private and public and personal rollups will continue to blur. Just like, people have Urbit like running on their machine, and it doesn't really connect anywhere, but like it's doing something. So I think, like, just as a technology, it makes sense. And whether or not those will all be interoperable, I think is like maybe a different question.
Yeah, that's fair.
I know, like, yeah, the super chain is kind of maybe leaning into the economies of scale you get from like a bunch of rollups being interoperable, but there maybe is like some sort of fundamental physical limit you hit from just like trying to do consensus across all these different things, and we get basically back to like Ethereum L1. So I think there will continue to be kind of like a sparsely connected topology. That's at least my kind of thesis that it won't be this like, I guess, fully connected graph, because that starts to look more and more just like Ethereum L1 throughput, where you have to do consensus across all these things. So, but yeah, I think just maybe reasoning by analogy is bad, but like this is like the microservicesification of Web3, in my opinion. Like we're gonna have application like special purpose rollups, and there's so much. There's so many teams who are building towards that vision. Like, even if all of our projects fail, I think there's just so many people who have bought into that vision for the future already.
Yeah, it looks like an S-curve, I think. Like, do we really need more than OP, ARB, and some other roll-up? Like, I honestly use like maybe 2, 3. It'll become, everybody will launch a lot of rollups, and just like we've seen with DeFi forks, right? It's gonna, at some point, it's gonna hit a, it's like, market's not gonna accept any more L2s, and that's probably the convergence. And that's where people will start building applications. And, because like, building good applications is possible right now. Like, you can build pretty cheap apps on like ZK Sync or somewhere. Like, I think that's going to evolve into eventually, hopefully next year or so.
Very interesting answers. And to the point of the upper limit, you were speaking to it from the just scalability perspective, but even from like a paying out restaking yield perspective, that's a huge focus, just a little shill of the SSA is thinking, how do we bring more people to this ecosystem who are outside of crypto?
And pay for it.
Yeah, I think
Yes.
the social coordination layer is super underrated. That's another, like, I think, physical reason for why rollups make sense as a roadmap for Ethereum. It enables people to parallelize innovation without having to coordinate on every EIP that like every single user of the chain has to adopt simultaneously when all the clients are going to like hard fork. So yeah, I think the social coordination aspect is actually like an underrated thing that we need to figure out and emphasize for sure.
So we're running a bit over. I'm leaning towards not skipping questions unless there's like someone out there is like a super fan of one of these projects and really has a burning question. Going once, going twice. Okay. Thank you guys so much for the super insightful conversation. I love that.
Thank you guys.
Thanks for having us.